when we talk about lists. We're not going to talk too much more about lists. We looked at BMI. We will be looking at BMI, which is weight over the height squared. And you'll learn that the expression for exponentiation is 2 stars. And again, PEDMAS is in effect. You don't need to worry about which one will be done first. Only use brackets if you know you have to do it out of order. We're going to talk, I guess, you know what, the rest of this stuff is going to come when we have the break, okay? Talked about PEDMAS. There are special symbols for modular arithmetic. Once you do the exercise, you'll get it. You can define functions the way I showed before using def. And there's 2 modules in there that you'll cover when we take the break. Import random and import string. It allows you to do things randomly and do things with strings. Okay, don't repeat yourself, iterate. The name of the game. Printing the first 5 letters of the alphabet. Okay, give me a second. How are you going to print the first 5 letters of the alphabet? In Python. You can do it right now with that. It's starting to heat up here. You could print A. Notice it's not A on its own. If it was A on its own, you know, without the, let's say I did just A, what's that? I don't know. It doesn't know. A is not defined, okay? It's thinking A is the name of the variable, okay? And we can't use A on its own. We have to use it as a string if that's what we intend, okay? Now we get A. Okay, so likewise, you do the same thing. Repeat, 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 and you get exactly what you wanted. A, B, C, D, E, done. Okay. Now, if you show this to anybody at work and say, "Oh, I've solved the problem. I've got my first 5 letters," they're going to roll their eyes at you. Okay, because programmers are lazy, and lazy for a good reason. Okay, we are lazy because we don't want to keep typing the same thing over and over and over. It's tedious. And if we want to change the way this is done, now I've got to do it 5 times instead of 1. There's got to be a better way, right? Well, you're right. That don't repeat yourself principle means just that. Don't do this. It came about, gosh, almost 20 years ago. Dave Thomas and Andy Hunt put out this book and stated that every piece of knowledge must have a single, unambiguous, authoritative representation within the system. Okay, so here we have knowledge. Okay, what's our knowledge here? It's the letter A, whatever that means. Okay, but it's there. This is the thing we're trying to use and impart in our program. Okay, A is not reusable. If I need to go and refer to this piece of knowledge again, I can't. It's locked away, hard-coded in this print statement, and as soon as we run the print statement, A doesn't exist. There is no A. It's gone. It'll show up on your screen, but you can't go and refer to it again. Okay, if you ever need it again, you're going to be hard coding it again, and that's really bad practice. And the structure for printing, we're printing, 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 always the same. It's repeated. Okay, so one thing you can do, there are many ways to solve this problem, but you could put your 5 values in a list like that. Okay, I'm just using ls. You can call it whatever you want. You can call it dog biscuits equals A, B, C, D, E, fine. Okay, and store the knowledge in a variable. Okay, if I want to get my A again, all I do is refer to the list and put these little brackets, okay, indicating that I want the 0th element. Okay, these are 0 index. That's the 0th thing in the list. That's the first thing in the list. That's the second thing, the third thing, and the 4th thing in the list. Okay, so if I want my A, I refer to ls0. There are many ways to do this. I'm showing you this one because I want to talk about lists. Okay, if we want to print them all, we can iterate. Okay, remember our variable again? That's a list. That 4, 5, 6, and then the string 7. Notice how 4, 5, 6, they're both integers. 7 is a string. The list doesn't care. You can think of a list as a bunch of cups in a cupboard. Okay, only one of them is enclosed in brackets. That's that one. Okay, and what type is it? Again, we did this earlier. I could give that to the type command, and will return the class of list. Okay, the list can contain many values. The values types can differ. Lists are indexed. and ordered. Okay, I talked about the indexes just a few seconds ago. There they are written out for you, and they're ordered. If I get the third, if I ask for index number 2, it's always going to be C. If 100 lines of code later, I again ask for index number 2. If I haven't changed the contents of the list, it will still be C. Okay, the order is explicit in lists, as opposed to other data structures where they're not. And lists are 0 indexed, as we talked about. Okay, ls0 gets the first element, which is A. ls3, 0, 1, 2, 3 gets you D. Okay. So in Python, the list is a type of thing that is iterable. Okay, and iterable means that what you have inside of it can be gone over one element at a time. Okay. An iterable is any Python object which can return its members one at a time. Lists, tuples, we're not going to talk about them, and even strings are Python iterables, okay? So you can iterate over a string, which is useful, indicating there's another way of doing this. Okay, Python provides a syntax for unpacking the contents of an iterable, assigning each item its own variable. Okay, this allows us an intuitive way to loop over a list or any other iterable. Okay, and here's how it's done. This is just a repetition. There's my list of 5 elements, and I can say for letter in ls, why did I choose ls? It's short for letters or list. You can say what you like about it. And then print the letter, okay? So what are we going to do here? Well, the first thing this statement is going to do, it knows, it checks and tells you if it's not, if this is an iterable. ls is an iterable. The very first thing, it's going to get the 0th item, and it's going to stick it inside letter, okay? And then we have this colon here, and then everything else below it is indented, okay? That means that this word, phrase, line below is the block, the body of the for loop. So for letter and list, A goes into letter, and throughout the body, letter exists. Okay, and then we can print the letter. Done. A is on your screen now. Okay, then it goes around to the top, and it fetches B, and it puts that in letter, and then it prints letter. Then it goes around again, and it grabs the next thing, and it sticks that in letter, and it prints letter. Then it goes around, you get the idea. D goes in letter, it prints letter, and then it goes around, and E goes into letter, gets printed, then it goes, wait, there's nothing left, we're done. We end up running the next line of code that follows. That's it. There's no magic. And we've condensed 5 lines down to 2 lines, but we've also made it reusable because we can get our data back anytime we want. And we've also only got 1 print statement. Okay, if we ever decide we want to change how it's printed, maybe we want to print it somewhere else or write it to a file, I don't know, you change this line of code rather than changing, you recall, a lot of slides, rather than changing that 5 times. Okay, back to the Jupyter Notebook. This time it's the don't repeat yourself. Okay, and you recall, you get that. You can expand this. We're going to get rid of it again, hide it again. Don't repeat yourself. Double click that. It'll open right next to it, which is fine. Okay, and we're going to just, I don't think there's a whole lot you got to do here, but I want to talk about postal codes. We all know them, postal codes. They have the very specific characters arranged, alpha, so that's like a letter and a number and a letter, followed by a number and a letter and a number. There's a space in the middle, okay? That's the format for it. I know you all know that. But you may not know that D, F, I, O, Q, U, W, and Z are not in the Canadian Postal Code. They don't exist in there. They're not used yet. Okay. And in addition to that, the letters W and Z are never at the beginning. Okay, so there's a couple of rules about postal codes. What if we were going to, let's say we have a task to do that is to, let's make all the postal codes, okay, because we need that as a starting point for some project. Okay, so you got the rules. there is a thing in Python built in, you don't need to install anything, called range. Okay, and if I'm going to do the trick, turn that back into code. I'm just going to run this manually. Range 3,6. Okay. Now, what we get that if we do this, unfortunately, is I think I need to put a print statement in front of it. No. Yeah. No, I got to do this. Okay. I'm sorry for trying to live code. Never try to live code in these things. Python itself is lazy. Range is a thing that computes a range from 3 to the end. Okay, and it'll go ahead and do that, but it won't actually expand to the range until we use it. Okay, Python doesn't bother. If I'm never going to use this range, it doesn't go ahead and calculate it. Now, if I put this within brackets, I'm going to cause range to expand into a list. Or not. Okay, like I said, never live code. Let's skip on and do this one. For A in range, this is the better way to do it. Range 0 to 9, print A. Okay, if we run that, and I just did, you get a bunch of numbers spat out. Okay, and it's the same thing. Python's going to ask range for what its next value is. Okay, and it's internally going to compute the value. Okay, it starts at 0. So the very first time you use this, Python says, range, give me the next number. It's 0. Okay, you know this. A becomes 0, print A, there's 0. We go around and repeat that until range says, I don't have any more numbers for you. Okay, and you'll notice that I said 9 at the end, but it only printed to 8. Okay, and that's the way they wrote it. Okay, if you need 9, then you change this value to 10. Try that and run it, and now you got your 9, right? If you actually want to see 10 there, you got to go to 1 plus. There you go, and there's 10. Okay, so that's great. But really, we started with 9. 9 is what we want for that. Okay. I could say this is the better way to do it. You construct a list this way. PC numbers. Python's laziness is sometimes hard to escape. This won't escape it. If I turn range into a list by calling list, then PC numbers becomes a list right off the bat. And if I print that, I get my list. Okay, 0 through to 9. And that happens to be the range of numbers in a postal code. You have 0 in it because the second digit is often 0 in postal codes, indicating that it's a rural area. And we know they go all the way up to 9. Okay, so we don't repeat ourselves by typing letters that already exist. You wouldn't type that out. And then you wouldn't type out all the letters manually, because if you try to do that, you might actually make a mistake. Okay, so we can ask, we have to import a standard library module called string. Okay, and this is a toolbox, right? We saw earlier, I think this is the first thing we've imported. Anyway, if you import string, you get to use things like string methods, okay? And string happens to have a representation of all the letters in uppercase, which is handy. So we can convert that to a string and stick it into PC letters. If I shift enter this, I'm printing the PC letters. There they are, A, B, C, D, E, F, all the way up to Z. No numbers in there, there's no punctuation, it's just the letters. And they happen to all be uppercase, which is part of the spec. Okay, now we know from reading the long documentation produced by Canada Post, it's exciting stuff, let me tell you. D, F, I, O, Q, U, W, and Z are not in there. Okay, so we are going to, and we also know that W and Z specifically are not used in the first letter. Okay, but they can appear elsewhere. So we're going to make 2 other variables. Postcode letters not in use, and there's your DFIOQU. And the first letters that are not in use, notice I'm spelling it out so that later on you don't scratch your head. What is that variable? It's the first letters not in use. Some programming languages really encourage long variable names. I find it quite useful for this sort of thing. Okay, I know it's really simple, but there it is. Okay, now run this. It's not going to do anything, but it needs to store values in these variables. Okay, and that doesn't happen. Notice that I've got a number 10 in there. Okay, and this one doesn't have any number. This means that this was the 10th thing that was run. Okay, and in this notebook. Okay, and we haven't run this one yet. So now I've got my PC letters not in use. So I'm going to say for letter in PC letters not in use, take the PC letters that we made up here, this big long, every letter in the alphabet, and remove the letter. Okay, so we're going to remove something from a list. And just to make sure we're good, we're going to print them so we can see what's going on. Okay, notice that this one ends up here. These are all monospaced, and we've lost a bunch of letters. You can very quickly, is D in there, A, B, C? No, it's not. Okay. Excuse me. Okay. All right, I'm back. So there we go. Now we know PC letters are good, but we also know that the very first letter of postal code is a different set of letters. Okay, specifically, it doesn't have W and Z. So we're going to make a copy of PC letters. Okay, and how do you make a copy? See, you can just read it. And it's fine for me to say that. You need to know that copy exists, and that's where experience and consulting documentation come in. But I'm telling you right now, PCLetters.copy is what you want. It creates a PC first letters, which is a copy of this one, and it's separate from this one. If I modify PC first letters, PC letters is not changed. Okay, so I don't say, I can't remove the copy. If I remove that, if I change one, the other will also change. So you need to make a separate copy for it. Okay, and then I can loop through that. For PC first letters not in use, remember that's only these two letters up here. Remove them from PC first letters. Shift enter that one, and we run it. And I think we're done. Let's do this. If I make my screen a little wider here, okay, you can see that PC first letters was printed out to the screen first, and it's 2 letters shorter, and W isn't in there, okay, and Z isn't in there. So we're pretty confident this is what we want. That can be, this represents the sum total of all the first letters, and then other letters in the postal code is represented by the second one, and numbers are represented by the last thing that's printed out. Let's make our postal codes. I'll declare a brand new variable, all postal codes, and I'm going to set it to that. Okay, that signifies a list, but it's empty, nothing in it. Okay, I'm also going to, this is the one I really need. PC is a little helper. Okay, it's a string. Okay, I don't really need to declare it there, but I want to show you up in advance that we're going to fill this with these. Okay, and we saw for loops before. Okay, and now I'm going to say for A1, I'm keeping it short now because it's the alpha 1, the first letter in PC first letters. For each things of those, run this entire body. Okay, you following this? For the second thing in there, which is a number in PC numbers, run all of this, and so on and so on. At the bottom, we end up iterating over all 6 positions of the postal code. Okay, and PC is at this point, now we're finally actually got some code. We're not in the, this is the body of the loop that will actually get run. PC is going to be set to thing, space, thing. Okay, and we can call dot format, which is a method of a string, and fill it with all the things. Okay, so you remember I said, you know, we're going to go grab the first letter and put it in A1 and then run that. That happens. There's no way a human being could, well, maybe they could for this one, but to comprehend and keep track of that, it's not something that people do. Python has no trouble keeping track of all of this. So I'm going to run it. Keep your eye on this little bracket here while I shift enter it. Okay, star means it's processing, thinking and thinking and thinking and thinking and thinking and thinking and still thinking. And that took a little while, but it finally got done. And now, before you go and try to print all postal codes, don't do it. We're not in the big data scenario. This is small data. If you tell Python to print all postal codes, it will print all of them, and it will tie up your machine for, you know, a good 5-10 minutes. So don't do it. Instead, let's find out some information about it. Okay, and here was that thing again. There are postal codes, dot format, and get the length of all postal codes. How many do we have? Okay, we group them by threes. There's the middle three, 7.2 million postal codes. Okay, and like I said, this isn't safe to go and print. If you try to print that, it's going to print out 7.2 million postal codes, okay, which we don't want. Okay, now there's other methods here. I'm going to skip a little bit of this. Not so much. Let me go through it fairly rapidly. If I want to print just the first 10, I can subset it. These concepts apply to big data as well. I can say all postal codes. Give me, instead of, you know how I can we did it before. I can show you the second one, which is actually the third position. Okay, and you get that. I can also do 2:10. Is that right? And I'm going to get, what is that, like 8 or 7 of them. Okay, I wouldn't try to print the whole thing. Okay, but you can just print a sample of them quickly like that. If you want to print the last 50, you put a little minus, or the last 50 minus starts at the other end, this end of it, and it'll do the 50 last ones. And just to say, you know, let's change this back to 0 and run it again. Okay, A0, A0, A0. That's what we'd expect because it's the first of everything. And likewise, down here, it's the last of everything. Remember, Z is not in the first letter, so therefore, postal code that's last doesn't start with Z. Okay, but everything else is last. 9 and Z there too, right? Okay, you can do a query. You can ask, is V8W2Y2, that's UVic's postal code, is it in all postal codes? And you get a value true type. True is a Boolean type. It's either true or it's false. It's not a number, it's not a string, it's not a list, it's a Boolean. Okay, and you can use these in logical statements later. What is the index of V8W2Y2? Where is it in the list? We need to know that. It is 6,352,582. Okay, and so on. Okay, you guys can run through those as you like. Okay, and there are more complicated expressions, but we're kind of going beyond what we really need to. You can subset this, you can filter it. Give me the ones that are, give me all postal codes that start with AOA. You want to do that. This is the expression for it. You can run that. It takes a little while, and it just counts them, right? There are 2,000 postal codes starting with A0A. Need to know it. That's how you do it. Okay. And from random import sample, I'll show you this one because we didn't do that before. Random is a module, part of the standard library. It's you don't have to download it or install it. You know, I say things like that, it just suddenly occurs to me that I'm not sure that's true. You try running line 23, if you'll have had to run everything above it. But this will give you a random sampling of all the postal codes, okay, and 12 of them. Okay, here's 12 random postal codes. HOH, OHO is actually in Montreal. My understanding, it's good to pick that up, is that that's the postal code of Santa Claus up in the North Pole. But you're right, it's actually in Montreal. It is. That's where the mail goes to be answered for all the kids sending messages to Santa, which is a fun fact. Exercise, that's for you to deal with, is to get the forward sortation area. Okay, your challenge is to randomly sample all postcodes and retrieve 20, keeping only the first 3 characters. How do you do that? Okay, I'm gonna give you step-by-steps to do that. Okay, wow, we are actually not too bad. Okay, back to the slides. I hope I'm not going too fast. It's tough for these things. The first time I've done this thing, so I may have to trim it for next time. We talked about iteration just then. We talked about the don't repeat yourself principle. It's a contentious issue. Those of you who have gone through computer science, I'd be surprised if any of you have. You will find that there are reasons why you should repeat yourself so that you do your abstraction correctly. But at this stage, a don't repeat yourself is better than what we call wet, which is we like typing. Okay, we use lists. They are ordered, and that's extremely useful. Remember, though, that the indexing of lists starts at 0. Iterations on lists can perform millions of ops. We saw that. We generated almost 10 million postal codes in just a couple of seconds, which is great. Strings are iterable if you want the third thing. I remember that 0, 1, 2, 3. The third thing, the third index, which is the fourth letter, the foobar, is B. And if you use the conditional expression double equals, you get true from that, which is great too. Very useful. Iteration is idiomatic in Python. Once you're used to the syntax of it, you are golden. Once you get used to it, it gets very easy to write. Random sampling. You got way too much data. You know, we've already gone past the limit of Excel by our 7 times 10 to the 6 postal codes, right? And Tim Towdy, I never actually spelled it out. But it means there is more than one way to do it. That should be an I at the end. So my typo. Tim Towdy, there is more than one way to do it. Okay, moving on. Using libraries. I think this is one we're going to do before the break, and during which you can continue on with the exercises, should you choose to. So other libraries. Okay, we saw a couple of things in the standard library. We saw random, we saw string. Okay, we should do this. We use libraries. You really should use libraries. Don't reinvent the wheel. A, it's hard. B, you're going to make mistakes that they've already thought of. And C, it's hard. I know I repeated it, but it is hard. If you've got string methods that know what they're doing, go and use them. If you want to do random sampling, don't construct a random number generator from scratch to sample things. Use random. It's thought of corner cases that you haven't come across yet. Okay, and you want to speed things up. We are using high level of abstraction here. You don't want to write low level code where you can avoid it. Okay, that's pretty well it. So let's look at 4 data science libs. NumPy. We're not going to delve too deeply into NumPy, but I will show you Pandas. Pandas Bokeh for charting, and Geopandas for geographical stuff. Pandas relies on NumPy, and Pandas Bokeh and Geopandas extend this. So the core library here for data science is Pandas. Okay, and here we go. There are 2 core things in Pandas. One is a kind of a list called a series. Okay, and there's very, very good reasons for using it, which we'll demonstrate. And a series, is used to create columns of data, if you like, to store within data frames. So think of a data frame as a table, like tabular data. Okay, it's got rows and columns. Okay, where the columns are series. Okay, so if you import NumPy as NP, this is typical, the import statement. NumPy is the library that we're importing. Okay, and we're going to give it a nickname. We don't want to be spelling out NumPy all the time because why? Because programmers are lazy. Okay, and typing NP is easier. That's why. You could just import NumPy and then import Pandas, and you'll have to say Pandas every time we've got a PD here. Okay. But the convention is to use PD for that because you're going to use it a lot. Okay, so PD.series, we're going to pass it a list. And inside the list is a whole bunch of stuff. Okay, most of them are numbers. Now recall that the list itself can contain mixed types. Okay, these are all integers except for this funny thing in the middle, nan, which stands for not a number, comes out of NumPy. Is right in the middle. So we got a value of like nothing in there. And that's perfectly allowed in a list. Typically though, when you think of a data table, your columns should all be the same data type, generally. Okay, and there are some exceptions where they're not, and this is one of them. Okay, so the list doesn't mind that, but by convention, you'd expect this to be homogeneous. Okay, S, we're just gonna give it a quick name, S, short for series, PD.series, all of that. And then we're going to print it out. Okay, and what we get is this. And it looks a little bit like a table, okay, but don't be fooled, it's not. These are, so the series has an index, okay? I know list has an index too, but this index can be whatever you like. By default, it's just got the numbers of the original list's index, okay, because we didn't specify. But you could have categories here, or you could have anything you like, as long as they're all unique. So I guess categories doesn't make sense in that case. Okay, and what is it? It's promoted all the values automatically to a float, because that's what it does. Okay, there's a lot of documentation on series and pandas. These two are links to get to the documentation. There's too much to discuss about it right now. Okay, but there's a quick preview of what it looks like. Okay, data frames, again, suddenly they get more complicated. We're going to use some helper methods. We're going to need a bunch of dates for our made up data. So we are going to call pandas and ask the date range method to create a range of dates. And this is super handy if you need to make a structure for some incoming data and you want to pre-populate it with formatted dates, or not even formatted dates, but dates. Okay, so 2021-07-06, that's today. Start our date range there and give me 6 periods, okay? And if we print that, we're going to get this part up here, okay? It's 2021, they're all strings, 2021-07-06, 07, 08, 09, 010, 11, okay? Exactly what we want. And then a little bit of metadata at the end, okay, which is what we want, okay? And that makes a date series. Okay, and we're storing it in a variable called dates. Dates isn't something special. You could call it figs if you want. You can name things whatever you like, but try to stick to names that are meaningful. So we're going to make a data frame, another brand new variable df. We haven't used it before. pd.dataframe. We're going to make a brand new data frame with random numbers. Generate some random numbers. For the index, we're going to use dates for our data frame, which is handy. And we're going to make columns. We're defining in advance what the index is going to be, and we're defining in advance what the column names are going to be. Okay, and it's going to be 4 of them. And if we print the data frame, we got our data frame. There's the index. Okay, so our dates. Notice there's no column header over it. It's the index, followed by 4 columns of randomly generated numbers. Okay, the 6 refers to, I believe, the precision. And I believe the 4 is makes 4 of them. Okay. So, you know, this might well be easier to do in Excel for this trivial example, but it's not when we start talking about large amounts of data coming in. Okay, that's just to remember that's pandas relying on NumPy in the background to generate some of these things. And the main reason you use pandas is to get the data frame. Use data frame in R. In Python, it's called pandas. Okay, pandas bokeh is the next library we're going to look at. And here's how you do all your imports. NumPy has to be first, then you load pandas, then pandas bokeh, which extends it. Okay, so again, don't make a brand new random number generator. You've seen now with this one, now there's 2 ways of doing it. NumPy has a random number generator, and so does import random. Okay, here we're using NumPys because we're sticking with this family of libraries. Okay, we're going to make a brand new data frame. This time, we've got this odd expression. Don't worry about the syntax of this. It's just a shorthand to get data into there quickly. Again, a whole bunch of random numbers assigned to the key Google, and another whole bunch of random numbers that are slightly less assigned to the keyword Apple, which is great. Index is going to be a date range, just as before. This time there's 1,000 of them. So some substantial data coming in here. We're running a, this sum is a cumulative sum. Instead of having just a random number all the time, we're going to start adding and accumulating the sum and storing that data, storing the accumulated sum as the data rather than the individual values, okay? So we would expect this to ramp up in a random fashion, okay? And for some, whatever reason, the illustrated example here shows that we're going to start at 50, okay? And now the reason why we got pandas bokeh, and we're talking about that, is that once we've got our data frame, we're going to plot it, and we're going to make a line plot out of it. Okay, and we end up like this. This is not a stock device. These are random numbers. These are not stock. Don't go buying any stock based on what you see here. And the neat thing about this, if you do this, we'll show you in the, I've got an example of this in the next notebook, but this thing is an interactive tool within the notebook. Okay? I'm showing you a static picture here as a result. Okay? Why use Pandas bokeh? Because this gives you a way of plotting numbers easily. Okay, we're going to move on to the third one, Geopandas. This is all about dealing with geospatial data. Okay, again, NumPy, Pandas. We're not using bokeh this time, just using Geopandas. It has data sets built in. Okay, it's got a map of the Earth built in. It's also got a list of the cities and where they are. So we're just going to take advantage of that and just store that temporarily. Okay, we're going to read a file. So these are, I separated it out. These are locations of a file that Geopandas understands, and we're going to tell Geopandas to go and input that file. Okay. And so we're not using cities at the moment. And the next thing we're going to do is print world .head. Okay. And this just gives you some idea of what's in there. I don't have enough data here to tell you what cities what. Whatever this city happens to be in the first row, they have just less than 1 million population. Whereas this one has, where's the second? It's 53 million, and there's billions there as well. Okay, so take your guesses as to what the particular city this is. But it is a city, and it's got this complicated multi-polygon shape. It's just data, but it's geographical data and metadata. Okay, and if I say world.plot, that's this one here, read the Earth and plot it, you get a plot of the world. And notice how all the little lines are in there, so that you could use this data to fill them in should you want to. Okay, Python is often described as a batteries included language, meaning that you don't have to dig around installing and making a whole bunch of stuff. There are lots of tools and widgets that do things for you. Okay, back to the notebook. This time we're looking at the using libraries. Okay. There's a bunch of stuff to go through here. This is what you just saw, so we can actually go ahead and run it. I'm going to shift enter it. Takes a little while. And there's one thing that wasn't shown in the slide, and that's this. If you are using this in a notebook, you call output notebook, and that integrates the output of Pandas bokeh into the notebook itself. So that interactivity will work in here, otherwise it won't. Okay. Anyway, so there's world.head, so there's a bunch of continental data there for you, and that's great. And world.plot, let me just run this one. Okay, and there's the plot that we saw earlier. It's not very elaborate, but it shows you that there's something there. And you get this little bit of metadata up here that you really don't need. And notice that so far in Python, we haven't used semicolons to end the lines. Often in other languages, for this print statement, we have a semicolon at the end indicating that that's the end. Okay, Python doesn't require them. Okay, but through some magic, they're used in these data science libraries. And all they do is they suppress this extra bit of information. Okay, so if I run this one, I'm going to get the same map again, except without a little bit of junk at the top, which we really don't want. Okay, so in your data files, you have some pulse code data. Okay, it's an 82 megabyte thing showing the geographical shape for every forward sortation area in Canada. What's the forward sortation area? It's the first 3 letters of the postal code. Okay. 82 megabytes. My machine's reasonably fast. It took a couple of seconds to do that. Your volume, your performance may vary. Okay, so there it is. It's there. We won't talk about. We're going to deal with big data later, right? Okay, but you can try to print that. It's safe. Okay, and from that we know by reading the documentation, it's all in here, that the provinces have specific IDs. Ontario is 35. It's got a PRU ID of 35, and Manitoba, for example, has 46. Okay, so I'm going to use that information and go and take out Ontario from this enormous data file. I'm going to take out Manitoba from this enormous data file by using these expressions here. Okay, it's almost instantaneous because it's all done by reference. Okay, and let's make a data frame. Okay, it's a very simple data frame. PD.dataframe, that's how you start it. We're going to give it this thing within curly braces, which basically means what's inside of here is key value pairs. Okay, notice that it's P code colon some stuff. Okay, and then it's A colon some stuff. Okay, that's all that is. It's value, name colon value comma name colon value on forever. All right. So I've got a couple of, I know in advance that when the middle letter number is 0, it's rural. Okay, as if they have larger numbers, that means it's urban. Okay, so I've got 3 rural areas and 2 urban ones. Okay, and what's this? This is just some numbers I randomly typed. But they don't matter. I didn't need to engage a random number generator. I don't want to actually, because I want these to be the same for you as they are for me, so that you have some confidence you've got it right. Okay. So I'm going to store that into my data frame. I'm going to shift enter that so that it runs. Got a number in there. I know it ran. And now I am going to join this data frame to my Manitoba data frame, which we declared up here. There. Okay. Don't worry too much about the syntax of it. Just try to follow along by example. The exercises, you're not going to have to construct this by hand. You're going to have to make changes to things like this. Okay. I'm going to run it. Now we have one great big data frame that combines this with the geographical data. And we're going to plot it. Okay, and there it is. Now, like I said, this is now, I can click and drag in here. This is completely interactive. Okay, this is something you don't get with Python on the command line. This is super useful. Okay, now we know that most Canadian provinces, most of the landmass, and all of them, even PEI, is rural. Okay, so most of this coloring, if I hover over it, see that's R0B. Okay, and the value is 3. Now look up here, R0B, that's 1, 2, 3. And if I count 3 into here, it's 3. The value is 3. Okay, and that gives me some confidence that this data is aligned. Okay, there's another rural area. It looks like it's R0G is down here. If I move that and scroll with the mouse wheel, you'll quickly see that, you know, we've got 2 very large areas, R0G. If I zoom in even further, there's Winnipeg, and there's, you know, R2 and R3. And look what happens. I didn't tell it to do this. It's grabbing stuff from the internet and filling in our map for us. Okay, which is really, really super cool. Okay, we like this a lot. Actually, this is an error up here. That simplifies shapes should be something much higher, like 20,000. Okay, I'm just going to run it one more time before we take our break. I just want to show you that this data is a lot. There's a lot of lines for the thing to draw. You can simplify those boundaries so that they're much simpler geographic shapes. Why would you want to do that? Because it renders much more quickly. Okay, like that. And if you don't want to simplify any of these shapes, whoops, wrong character, comment it out. Comment in Python is hash. Anything after the hash is ignored. So in this case, that line doesn't exist as far as Python interpreter is concerned. Run it again, 3, 4, 5. It takes a little bit longer. Okay, but your resolution is vastly improved. Okay. Postal codes, except for inner cities, here's a complicated line that it drew for us. Okay. If you ever look at B.Sc's data set, we have a lot of coastline in B.C. The B.C shapefile is much larger. It takes much longer to render. Okay, that's fun. I'll leave you to do an exercise. Let's do the same thing for B.C. I've given you a scaffold here. Try to work your way through it. What you should end up with is a bunch of random postal codes. You're going to do that. And it'll show them on B.C. I love that you can just, this is all for free, right? Zoom in and see the shapes of buildings. Fun stuff. Guys, I don't know Winnipeg well enough to show you where the university you're at is, maybe you can find it. Okay. So that's it for that workbook, except for the exercise that's remaining. Why use libraries? Because Python is a batteries included language. I'm going to jump ahead one. That's fine. Okay. Batteries included. So it's great. The standard library has a whole bunch of tools that you can use. NumPy is there as well. Pandas. You guys, were you able to run those? You may need to install Pandas and NumPy. Okay, I'm going to stick around during the break. I'm going to go refresh my cup of tea, but then I'll be back. Sorry, I'm just lost the train of thought here for the break. Looks like we are coming up to the break, so that's fine. Let's take a break. And while we do that, continue to work on completing the notebooks.